Okay, well, so hello everybody and welcome to this webinar on renewable energy communities. So today we'll be doing this webinar in English. I know that a lot of you are French, so we'll accept questions in the chat in French, so don't worry, you can ask your question in French. So for today's agenda, we will start things with a small introduction of 15 minutes by Raphaël MEYER and Trevor HINCKLE on the context of this webinar. And then we'll dive right in our main topic, which is renewable energy communities. We'll start with Rita Desmeyer, which will give us a point of view on the European regulation. We'll then move on to Rémi BASTIEN, which will talk about building those energy communities in France with Enogrid. Then we'll have Xavier Lambin from Grenoble School of Management, which will talk about sharing the value among participants in the community and what rules should be put forward. Then we'll have Damien PICAULT from ENEDIS, which will talk about the point of view of a distribution system operator and how to enable those communities. We'll have another distribution system operator. We'll have Youssef CHRAïBI from GreenAlp, which will also talk about the point of view of from the grid point of view, what it is to deal with those energy communities. And then our final speaker will be Margot Husson, which will be doing graphic facilitation, and she will be making some visual along with the presentation, and at the end she will comment those visual and try to share our view about this energy community topic. And finally, we'll have 15 to 20 minutes time for questions at the end of this webinar. So please ask your question in the chat and we'll be answering those questions at the end. No worries. So before getting started, I will pass the microphone to Marine, and she will give you a few tips on how to use this Act and Match platform.
Thank you very much, Nathan. Welcome everyone to the webinar. My name is Marine. I'm in charge of the technical organization of this webinar under the Act and Match platform. I wanted to give you some information for you to be as comfortable as possible for the webinar. So you can, if you want, decide to change the language of the interface to English. So this will give, the room will be totally in English. If you would like to also move the video pod to the top right corner, this will free some space for the content, the presentation. You can just click here on this button and it will move the webcams on the top right corner. You can also translate all chat contents to your native language or to English if you wish. You can just do that by clicking on this parameter wheel. And whenever you want to write a comment or raise a question, actually, I will activate the question mode. You can have either the comment button here, if you want to comment on the technical aspects. And whenever you want to ask a question, and we'll have some question sessions during this webinar, you can actually click on the question mark before you send your comment, and it will be marked as a question, and we can broadcast all questions. So feel free to do that when you have questions. If you have an issue accessing the sound or the image, you can try to refresh your page clicking on Ctrl+R. In case it still goes on like this, you can change your browser to Google Chrome, which always works better than, I mean, most of the times better than the others. And if you have any issue remaining, you can click here to access the sound by phone. It's VoIP. So in any case, you cannot have the sound, you can click on the event board and dial in the phone number. Thank you very much. I will remain at your disposal on the chat to help you out through the webinar in case of any issue. Thank you, and the word is back to Jonathan.
Yes, thank you, Marine. So we'll start right away, and I will give the microphone to Raphaël for kicking off with the introduction.
Good morning, ladies and gentlemen. And I would like to especially acknowledge Jonathan for preparing everything. Jonathan is preparing a very ambitious PhD here, and he's doing really a lot and very well. So thanks for that, and thanks to all of you for being here today. We would like, of course, to talk about many things. I can first maybe introduce Lancey Energy Storage. So it's a young industrial company based in Grenoble. We are 4 years behind us right now, and 35 people, and we are developing different kind of solutions. I will come back a bit later. But first, in order to introduce a bit the topic and what's the ultimate goal actually of all the works that we are all doing together within this group and within globally this ecosystem of energy, of electricity, we can just take a quick look back to what happened just before the corona crisis. For instance, the European Green Deal to target carbon neutrality in Europe by 2050. And there are some good news. I mean, even China announced this same objective for 2060. Of course, the results of the American elections can have an influence on that as well. But we can keep in mind that it's really among the top priority for the coming years, for the coming decades. And what we could observe just after the coronavirus crisis is this recovery plan that even emphasize the objectives of the European Green Deal. Our debate is, of course, not to create a direct correlation between the environment crisis and the coronavirus by itself. But by the way, of course, the two subjects are linked with those recovery plan. Our objective, the objectives, let's say, of those plans are, of course, to, in a way and with different ways, reduce the carbon emission to target this carbon neutrality. And usually it's pretty well accepted that the carbon tax rise is one of the most, if it's not the most powerful tool for that. But we can, if we go back in 2019, take a look at this yellow jacket crisis that occurred in France, and of course it has many different origins. But if we want to oversimplify, it's a bit carbon tax, constrained usage, and no possibility to invest. And into the end, what you get is this crisis, because you cannot into these configurations offer some options to overcome the direct impact of the increasing the cost of energy for the people. And of course, that cannot work, at least within a democratic society. So we have to work a bit differently. We know that in Europe, the heating of the buildings, it's more CO2 emissions than transportation. And maybe the building is less ego generator, but and we talk more about the EV car and all those subjects. But we have to keep in mind that actually the heating of the buildings should be as serious topic than the car electrification. And of course, we need to quickly implement a new generation of heating systems, of cooling systems elsewhere, in order to go with this movement of carbon neutrality. And of course, if we talk about heating of the buildings, we have to talk about the thermal insulations of the buildings in Europe. And this statistics is actually pretty concerning, as 3/4 of the European dwellings are inferior to label C, and only 3% are in label A. And this label is required actually to target carbon neutrality by 2050, and that just give an idea on how huge will be the investment within the existing building stock if we want to target this objective. So, in a way, if we want to again oversimplify the measures to be carried out, we have to, of course, increase the thermal insulation of the dwellings. We have to of course, use the energy in a better way with better efficiency, especially for the heat generation. We have to produce green electricity, and that will be, of course, one of the subjects with those energy communities that are, in a way, one possible interpretation of the carbon neutral society in Europe. And we have to keep in mind that, if possible, those options would be proposed or must be proposed without investment, at least for the 20% of European citizens that are suffering of fuel poverty. And that's at least the three last topics. The objective of the Solar Quest 1 project, a project that has, in a way, paved the way of Lancey and its partners. The objective is, of course, this carbon neutrality. Carbon neutrality means that we have to understand the sources of CO2 emissions. For our case, it's the electricity. CO2, electricity in Europe, well, you get it. It's the electricity map, of course, that you all know, which was established by Tomorrow a couple of years ago. And we've built, as it's the ultimate target, we've built this project with Tomorrow. And I would like to, at this stage, welcome on stage Trevor to present Tomorrow's activities.
Hi, Raphael. Thank you, and good to have you all here. So I'm just going to give a quick introduction to Tomorrow and what we've been doing and how some of the things we do relate to both energy communities and the topics that Raphael was speaking about. So just a quick introduction to Tomorrow. We are a climate tech company based in Copenhagen, and we started back in 2016 with the Electricity Map project, which many of you may know, but just to give a quick introduction, this project is both a visualization, which Raphael showed in a previous slide, but also the world's largest database of the carbon footprint of electricity. So we have a data pipeline that takes in electricity data from around the world, and particularly in Europe, we have quite strong coverage that provides a lot of interesting information, both for our open source project and for our commercial partners on the carbon footprint of electricity at any given time. And when we talk about the building stock of Europe, an example, we provide, in our work with Lancey and others, to provide the kind of carbon data layer on top of that, of how can we both descriptively and prescriptively manage and understand and reduce the carbon footprint through solutions like what Lancey has developed. So just a quick overview of how our project works. I won't get too deep into this as it can get quite technical very fast, but we work with public data. We apply this proprietary flow tracing model we've developed to account for the imports and exports of electricity, and then we extend that to create a marginal data model, which allows products like what Lancey has developed to adjust their consumption and allows individuals and companies to adjust their consumption based on what we think the grid will do based on an additional kilowatt hour of electricity. And so this is a way to help facilitate the transition to a more low carbon grid, because we're starting to consume when the grid is greener. So we can kind of smooth out these intermittencies in the grid that you might expect as we rely more and more on wind and solar. And it comes down to this question of how can we do a better job of decarbonizing our system by using electricity when the wind's blowing and the sun is shining. So just a quick introduction to our team. So Olivier is our founder, and he was the one who built Electricity Map. And then we also have Martin, Søren, Kenneth, and myself, who are on our leadership team working on Electricity Map and other projects. And we have backgrounds, many of backgrounds, including experience with climate and energy, and also at a lot of technology companies as well. So we kind of try and bring this intersection of climate and technology to our work. And a bit of information about what we've done, along with the great work we've been doing on Solar Quest 1 with Lancey. We also have been working with helping global companies track the impact of the electricity they use. So we're helping kind of push the world of carbon accounting forward to bring a more physical basis to the way that we understand the impact of electricity, as opposed to a kind of market-based contractual view. Then we're also working with more consumer-facing brands to engage their customers around the footprint of their electricity. And then along, we're doing a lot of, again, with Lancey and others, optimization work, as I mentioned before, so to help them understand the footprint at any given time and make some optimizations, load shifting based on this. And then finally, we work with lots of innovation projects, universities, NGOs to help them gain insights into the global electricity system. So now I'll turn it back to Raphaël to tell you more about Lancey and what they're doing.
All right, here we go. So, as was explained by Trevor, we have indeed a couple of missions that we want to implement. We strongly believe that decentralized energy storage is the best way to leverage the storage benefits for the people. We have these problems of heating in Europe, in France especially. We have this old stock of electric toasters, as we call them sometimes, that we have to replace. And we found a original exclusive interpretation of this decentralized energy storage by embedding a battery directly into an electric radiator. And that's basically the innovation of Lancey that will, into the end, among the different constraints that we can impose to our energy management system, take into account through an API the data of tomorrow regarding the electricity CO2 content. The idea basically is to have a system with all the sensors that can be useful for, of course, increase the energy efficiency for the heat generation at home and basically turn off the device as much as possible, but also prepare all the data that are required to propose progressively more and more flexibility, like demand response mechanism, fast containment reserves, into the final users, but without impacting the comfort. And more, we postulate that the energy efficiency will include, within the different parameters, this ability to, in a way, create a smart grid. So, in a way, impose into the final use, into the consumption, the constraints that are related to the production. And in this interpretation of Lancey, well, you have 1 to 2 devices per room. So in a way, you have a ubiquitous system for both this energy efficiency generation and, of course, those data in order to go to a more flexible electricity grid. We have this energy storage, 800 watt-hours of storage, lithium-ion in each device. It's a very modular approach in a way, as you can, with the same solution, equip from 1 studio to 10,000 square meter building. That's exactly the same solution. And you will have a proportionality between the storage needs and the energy need, of course. And you also have a 500 watt microinverter in each single device that can re-inject the power into synchronization, with the grid frequency. And that's critical, of course, for fast containment reserve, for instance. And the configuration that we want to build at the building level or at the dwelling level is this one, in self-consumption. So basically, you will equip 100% of the rooms with our system. You will put 20 square meter of PV panels, so 3 kilowatt peak of photovoltaics. And into the end, you will get 100% self-consumption ratio building that can cover from 50 to even more % of the energetical needs just with the rooftop and with this energy storage, which is divided a bit everywhere within the room. And last but not least, it's not the subject of today, but again, it's to try to keep as many constraints as possible within the same equation. And of course, if we talk about lithium-ion batteries, we have to consider all the drawbacks, all the negative impacts of the production of those batteries. And we don't want to hide them. It's a reality. It has an impact. And that's why we are working since the beginning, actually, with Groupe La Poste in France, in finding a second life, but without remanufacturing, so with a very cost-effective approach, a second life for the bike batteries that our friends from Paris know pretty well, the bikes from Veligo. It's a long rental long-term rental service for e-bikes. And we will collect those batteries, select them, and the ones that are good for a second life will be re-injected in a way within the electric grid. And with this hardware ecosystem, with these hardware solutions, what we want to propose as a model is an energy community model. As we postulate that, first of all, it's a way to mechanically increase the self-consumption ratio without over-investing into the hardware part. And without investing into this hardware part, it means that with a lower investment, if the investment is sufficiently low compared to the services that we can generate at the level of those communities, like just producing and selling electricity, potentially we have a revenue sources that is sufficient to reimburse the initial investment. That means that we have a business model that can potentially bring to this zero initial investment for the end users. You produce electricity, you have the storage system to manage this electricity, you have the local community as the consumption zone. That's the energy community model. And that's why at this stage I would like to go back to Jonathan that will introduce his PhD topics. Thank you very much.
All right, thank you very much, Raphaël and Trevor, for this introduction. Let's dive in right away with our first participant, Rita Desmeter, for European regulation on renewable energy communities.
Thanks, Jonathan. Thank you, everyone. Hi. So today I will be talking about energy community and different European markets with a focus on the collective self-consumption business model. So first, I would like to introduce you Delta EE. So we are a research and consultancy company, specialist of the energy transition. And we are based in Edinburgh, London, Cambridge, Paris, and Japan as well. In terms of research, we have one service research specialized in local energy system research. And we are publishing reports on hot topics such as collective self-consumption, but as well customer attitudes, blockchain. We publish market reports as well, case studies, database on policies, database on project as well. So we'll start about the energy communities in Europe. As you know, two different directives gave rates and defined the terms of energy communities as being legal entities with the Clean European Energy Package for All. So the first directive is citizen energy communities, asking participation of members that are in the proximity of the renewable energy projects. Shareholders or members are natural persons, SMEs, or local authorities such as municipalities. Their primary purpose is to provide environmental, economic, or social benefits rather than financial profits. And then the project must, of course, include renewable generation. The second directive, the renewable energy communities, is open to natural persons, local authorities that do not, they do not have to be in proximity of the project, contrary to the citizen energy communities. And then they may also include renewable generation and or energy services that benefits member or shareholder. So the European member state must transpose those directives into national laws, and they have until December 2020 for the EMD, Electricity Market Directive, and then until June 2021 for the RED II, Renewable Energy Directive. So in terms of business model of energy communities, we are seeing 4 different business models. The first is generation export, where members own generation assets, and then incomes from the sale for example, from a PPA, can be shared with members via dividends or be reinvested into the wider community. The second model, that's quite common as well, is the cooperative energy supplier, where community or publicly owned supply company where members own shares in generation assets. Members receive revenue shares and or cheaper electricity prices. Then the third model, which is the model that interests us the most, the model of collective self-consumption that I will define later. And then we have virtual allocation or peer-to-peer, which is public or individually owned generation assets shared virtually between members. So in some cases, prices for the electricity can be set by the producer. So we see that those four different business models strive to interface with value streams, while virtual allocation and collective self-consumption also seeks optimization and self-consumption, which is why it's quite interesting. So what we are seeing as well is that third-party involvement is becoming critical in enabling energy communities to create long value term. Why? Because originally, energy communities were aided by subsidies to achieve economic viability. And lately, as you probably all know, the subsidies have been reduced or removed in most European markets. And this requires energy communities to engage in more commercial and market-driven forms of value creation. So to engage in those more complex business models, there is a need to partner with third parties because of the expertise required to develop more innovative and technically complex energy systems. There's the financing part, where partnerships enable energy community to structure capital for project development and for operational governance. Then third parties enable energy community to access competent maintenance resource and optimization of assets. And in terms of technical skills, this can range from data collection to balancing or capturing system value. So in summary, the removal of feed-in tariff has been a catalyst for value-driven energy communities. So what we've seen is from Europe, the European policy dictates, policy dictates regulation, which in terms determines business model types. So collective self-consumption market is developing in Europe, and lessons from pilots are beginning to reflect. So what do we look at when we look at a collective self-consumption policy in a market? Well, first of all, is it allowed in the country? It's not allowed everywhere in Europe yet. What is the perimeter of operation? What is the maximum cumulated power? What are the possibilities of governance structure, organizations, asset ownerships? How is the energy produced allocated to participants? And what value streams are accessible to sell electricity, the excess of electricity, or sell flexibilities? So in Europe, at the moment, we see different national frameworks. And then some member states still lack some element of EU legislation. So we see that the models have been adapted with the cultural factor and the contextual factor. So what we are seeing is that in general terms, the Nordic countries, Nordics, Denmark, UK, Netherlands, can do business model based on collective self-consumption, but only on private grids. This is not yet allowed on the distribution, public distribution network. We see that the German-speaking countries have different models, such as the Mieterstrom in Germany, Switzerland, Austria. Greece has a little bit of a specific model with virtual net metering, but I will come back to this later. and then the Latin country with name around autoconsommation collective. So that is to give a quick overview on a map. And then we will dive in the different model. So collective self-consumption inherently is a business model and is one of the way of interpreting the intention of the CEP directives. So collective self-consumption is a local energy model which shares the output of pool generation assets amongst a group of consumers with the aim of optimizing self-consumption within the community. So the energy concern can be electricity only, but also heat, or it can be multi-energy vector with CHP, EVs, biogas, etc. And it can be managed through a legal entity such as association, companies, etc., but is not mandatory in every European member state. So what we're seeing is that collective self-consumption model have a legal perimeter. So it can be a distance, like in France, which is 2 kilometers or 20 kilometers in some cases. It can be under a substation. It can be restrained to the multi-family building, or it can have a wider perimeter, such as the neighborhood level. So if we look at the simplest form of collective self-consumption, is set at the scale of the building. Why is it more simple? It's because it simplifies the question of network charges, because when the energy is shared within a building, it uses the building own wiring. So we are seeing, for example, a country like Austria, where the perimeter is at the building scale, and the legislation is evolving toward extending to district level. Grid tariffs are avoided on a building, and to extend the perimeter, discussions on local grid tariff involve the idea that consumers would only use the LV grids, also pay only the LV grid-related share of the grid tariff. In terms of other markets that are constrained to the building level, we have Germany with the Mieterstrom model, which is quite well known. So the Mieterstrom allows grid fee and concession levy avoidance for energy consumed behind the meter. There's still a surcharge that is being paid by the energy consumer to finance distributed renewable energy installation, which is the EEG Umlage. The energy supplier also receive reduced feed-in tariff for the surplus of electricity fed into the grid. So the energy imported from and exported to the grid is netted against a single point of coupling, also called the Zumenzähler. And then behind the Zumenzähler, private meters register consumption for each tenant. So the assets can be partially owned by the tenants, the real estate agency that owns the building, or by the energy supplier itself. Then we see model set at a wider perimeters. But when the models are set at a wider perimeters, collective self-consumption operation becomes a little bit more complex. It also presents more opportunities, such as rural, urban, commercial, industrial, and campus areas. And in those models, a number of individual buildings are connected to the distribution network and managed by a DSOs. And this is why it becomes complicated. So we see that, for example, in Belgium, the perimeter is downstream of one or more local transformer. In Switzerland is behind the same CPP. So the participant parcels of land of building do not need to be adjacent to the production facilities, but no public area is allowed to be in between those buildings unless the municipality participates in the CEV, which is the Swiss collective self-consumption. So I will illustrate this with the French example. So the collective self-consumption model in France gather the producers and the consumers within a legal entity that is called PMO. This legal entity defines a consumption index depending on the consumer profiles and issues the bill. For the excess of electricity, there's no obligation from the DSO or EDF to buy the excess, so the PMO must find a buyer and have a specific contract, otherwise this is lost. For the residual demands, the consumer can ask the supplier of its choice, of course, and the supplier is balancing responsible. And the DSO allocates produced electricity to each participant within 30-minute intervals, applying the electricity consumption index given by the PMO. So the maximum distance is 2 kilometers with 3 megawatts maximum. And in some cases, it can be extended to 20 kilometers with a 5 megawatt maximum cumulative power, which is quite interesting in the countryside, for example. We see that some European countries have adopted 2 different regulations, one for allowing the multifamily building, and then one for the extended perimeter, which is the case in Italy, where both models are allowed, as well as in Slovenia and is in Spain. So this is a way to translate quite closely the European directive into regulation. And then at last, I will present the Greece case studies, which is a little bit specific because it's a virtual net metering system. So Greece set up this system not in reaction of not to translate the directive, but actually was a solution to tackle energy poverty. And the first model was a scheme that would allow typically a farmer or one public entity to install a PV system in one location. And then the consumption would take place in another setting, typically within the same prefecture. So prefecture is subdivision equivalent to a county or a borough. In this system, critics said that other stakeholders would like to be involved. And because the Greek grid does not have congestion problem at the moment, they would not have a problem to use the grid as a virtual storage. So they allow energy community scheme to allow bigger participants, so up to a minimum of five participants to a virtual net metering system. I think I'm running out of time, so I will jump directly to a last slide, presenting how local energy systems business model, so energy community, appeal comparing to other customers' proposition. And this is quite interesting to see that energy community ownership or peer-to-peer trading or locally sourced renewable energy are seen quite positively and appeal more to customers than heat as a service, for example, or home energy management. And this is quite true in most European countries. So in Italy, more than 40% of the people find energy community business model really appealing. Well, they are very enthusiastic as well, so we have to mitigate those results. But this is quite a positive image for energy communities in Europe. So thank you very much. And if you have any questions, don't hesitate to ask.
Thank you very much, Rita. Thank you very much for ending on this positive note. And now we'll have Rémi Bastien to have a look at the French regulation on energy communities.
Hi, everyone. I'm Rémi Bastien, CEO of Enogrid. Thank you, Lancey, for organizing this webinar. So I'm going to speak to you about energy community in France and specifically collective self-consumption. I will try not to repeat what Rita has explained quite well just before. And first, a little bit more about Enogrid, who we are and what are our missions. So Enogrid mission is to facilitate collective self-consumption in France for the moment, and we'll see about Europe after. So we offer different kind of service to people interested in collective self-consumption. First, we can train the future project leaders, train them to know more about these new models and how to launch their project. Then we help them for the support of the implementation of their project. And at last, when the project comes to operation, we provide a platform, a web platform to manage and optimize their operations, their collective self-consumption. As of today, Enogrid starts 2 years ago. As of today, we supported around 20 projects. Already 10 of them are in operation using our web platform. A little bit of Rex. Today, the projects are mostly with PV production, photovoltaic production, and the projects are mostly led by local authority and social landlord. Before diving into collective self-consumption, let's take a look at quick look at the French regulatory framework for self-consumption. So on one side, we have individual self-consumption, where one consumer produces his own electricity that he uses. And then we have the collective self-consumption, where electricity is supplied between one or more producer and one or more final consumer. And as Risa said, all of them has to be connected within a legal entity that we call PMO. So today when we talk about energy community in France, it's actually the collective self-consumption, this group of people making collective self-consumption who are the energy community. We have to make a little bit more detail, we have two models of collective self-consumption which are allowed by the law. So we have the basic one, as I call it, where we stay within the same building, and we can be either on low voltage or high voltage network. And on this case, we have no power limitation. And then we have the most common models, which is the extended one, where we are within a neighborhood. So we have 2 kilometers maximum between all the participants. Everybody has to be connected on the low voltage network, and we have accumulate maximum production of 3 megawatts. So actually, as of today, most of the projects of collective self-consumption in France are within the extended model. So now let's speak about a bit more about how to build this energy community, and what we have noticed is the start of the community is actually the creation of the PMO. So as we said before, the PMO has to connect all the producer and all the consumer of the collective self-consumption, basically all the participants. So it's really the heart of the energy communities, this PMO, which is a legal entity. So what are the common questions that we face? First, what is the most adequate kind of legal entity to be PMO? The French law let us the choice to choose any kind of legal entity, so people have to make a choice. So that's one of the first question. Then another question which can be asked is, can one PMO cover several projects, or do we need to have one PMO per collective self-consumption? So on this, the question is yes, one PMO can cover several projects. So we can imagine an energy community quite big with 2, 3, 10, 20 projects of collective self-consumption. Then some people ask us also, can an existing entity be PMO? For example, so that means, do we have to make an ad hoc PMO for each project every time? And the answer is yes. An existing entity can be PMO. You just have to be sure that it respects the requirement of the law, which is all the participant has to be connected within the PMO. And connected doesn't mean that they have like a contractual link. That is not enough. They have to be all part of this entity. Then when do you start working on the PMO identification or creation? I have to say, as soon as possible, as soon as you identified your participant of your future community, you have to quickly decide what kind of PMO do you need to create, or do you identify in order to start working on your project and to start speaking with the DSO. For the last question, what about social landlord and their tenant? I wanted to speak to you about this specific point because at the beginning, when collective self-consumption starts in France, social landlord has quite some issue to create a PMO to make collective self-consumption with their tenant. It was too complicated, and they couldn't get their tenant involved enough to be part of to join the new PMO. So now the law has changed very recently, and now a social landlord can be automatically PMO when he's doing collective self-consumption with his tenants. So that's simplified a lot the process for this type of project. Then a little bit of recs that Enogrid can provide about the PMO type. So we have noticed that when people are creating ad hoc PMO, they are mostly association, basically because it's an easy way and quite light way to do it. And there is, it's cheap, it's fast, and it does the job. So a lot of projects are going this way. Then you have to know that when local authority are doing collective self-consumption only between its own building, in this case, because they are both producer and consumer, automatically they become PMO. So there are a lot of projects where PMO are directly the local authority because they are making self-consumption only with their own building. Then we have seen also existing cooperative which are already there working on some other type of project, energy project, and starting to launch some collective self-consumption project. And in this case, they just change a little bit their status to be able to manage to manage the job of the PMO, so that that's working quite well also. And as I say, social landlord now are automatically PMO when they are making a project with their tenant. Then once you have your PMO identified and or created, what will be the job of the PMO specifically? Because that's the PMO which will hold the energy community and let's say discussed about specifically the DSO. So as I said, the PMO, I remind, it's any legal entity which connects all collective self-consumption participants. So that's a requirement from the French Energy Code. The first job for them, for the PMO, is to sign the collective self-consumption contract with a DSO, so ENEDIS or other DSO like a GreenAlp, for example. Then one very important job of the PMO is to define the production allocation keys. That means to decide how the production will be allocated between between the different participants. And then it's the job of the PMO to send this information to the DSO. Then the DSO, on a regular basis, receive all the energy data. The PMO receive all the energy data on a regular basis from the DSO, and after it's up to him to send this information also to all the participants. Last job of the PMO is to update the DSO of any entry or exit of participants. So if we have to sum up the PMO job quickly in one sentence, is the only one who, from the energy community, the PSO is the person who speaks with the DSO for all the organization of the collective self-consumption. So it's really a key job, a very important job, and that's why everybody has to be involved when we're starting the project to make sure that the PMO will be doing his job effectively. To continue, I wanted to present you, sorry, it's in French, but I think we will understand. I would like to present you some collective self-consumption projects that we follow, few of them, which I found quite interesting. So the first one is one in west of France, where we have production on public building, technical public building, and then the energy is shared with all the businesses around this building. So there are there are 2 restaurants, 3 shops, 3 businesses, and so on. So this project is working quite well since August 2018. Next project is quite the same, but with a specificity that it's a solar tracker, which has been installed close to the city hall, and same the energy is produced self-consumed directly by the city hall and the school, and then the rest is shared with local people directly. One project that I like to speak about because it shows also that collective self-consumption is possible not only with PV production, but also with other type of production. For example, here we have a hydraulic, very small hydraulic production source from 10 kilowatts. And it has been installed by the city, and the electricity produced is used by the city hall, by the school, and by all the public lighting all the time. And the last one, it's interesting because it's one of the few projects that we have witnessed so far that have been launched only by citizens, not by local authority, not by social landlord, but very directly citizens who decided to make collective self-consumption. So it's a group of people that built their own house, and directly from the beginning of the project, they decided to put solar panel and to share all the electricity between the 10 houses. Unfortunately, so far let's say it's a little bit too complex to do collective self-consumption. So for, let's say, for not technical citizens to do it directly. So that's why it's mainly led by local authority or a bigger company. I think that's it. If you have any question, I will be happy to answer.
Thank you very much, Rémi. Thank you for all those examples. And let's keep on going with Xavier LAMBIN from Grenoble School of Management.
Hello, Hello, Jonathan. Hello, everyone. Well, I will assume that if you don't complain, then that means then you do see me correctly and you do hear me correctly. So thanks very much for having me here and giving me the opportunity to present this small piece of work. So that's joint work I did with Ibrahim Abada and Andreas Ehrenmann, who are working with ENGIE. And well, surprise, we're going to talk about energy communities. The focus of this talk will be actually the gain sharing within the community. That is, basically, we observe that it's not so much that the energy community needs to create value overall for it to be desirable and for it to materialize. It's also important that once the wealth is created, okay, the value is created, then you find a way to share it in a fair manner within the community, in a way that everybody is satisfied with its treatment within the energy community. So yeah, not so much that you do create a big pie, but then you have to share the pie. And that's going to be really the angle we are going to take in this presentation. So I'm going to skip the motivation slides because I think Rita and Rémi did great work at motivating the issue and the institutional settings. So I'll assume you're motivated. And I'm going to dive directly to the research question. Okay, so the basic observation that we started from when we started this work is that communities are formed following cooperation. That is, the motive behind an energy community and the way it operates is cooperation between members. However, the interaction between the community itself and the rest of the system, and in particular the DSO, for example, or the other communities, is non-cooperative. Okay, so here we really have the two angles of game theory, where you have a cooperative game that is embedded into a non-cooperative game. So in this presentation, I will talk about these two aspects sequentially. It seems my connection is not too good. I really apologize for that, but well, I'll assume you can still hear me. So the first one will be to look at within the energy community, can they be stable? That is, they create value, and then how do you share the value? And in particular, we will show that most of the usual gain sharing rule, okay, so at the end of the year, you have made a benefit, you have to share it within members. Most of the usual sharing rules will fail to satisfy everybody, and therefore the community might collapse. And what we advocate is slightly more sophisticated sharing rules that will allow the community, in many cases, to actually survive. That's going to be the first point. Really, the allocation rule is something that we shouldn't neglect. And then in the second step, I will look at the systemic effect of energy communities. That is, energy communities, they form disregarding the rest of the system, and in particular, they will contribute less to, typically they will contribute less to grid cost recovery. And we will see that there might be a snowball effect in the sense that if one community forms, then it will potentially force the DSO to increase its tariff, which in turn might push other communities to form, while other communities wouldn't have formed absent the first move of the first community. Okay, so that's going to be really our two steps. So the first one is about whether energy communities at all are viable. So here is our setting. So we take collective self-consumption as a base setting. So we'll have a set of households who can share a roof and build solar PV on this roof, and they wonder whether they should join into a community or not. So well, more formally, we have a set of households here. We have theory and empirics. I will just focus on the empirics in this presentation. So N households, they will consume energy as usual. They may invest in PV panels. So that's going to come at their own cost. And then that will allow them potentially to save on grid tariffs. So in the first part of the presentation, I will neglect grid tariffs and come back to that later on. Then the electricity will be consumed locally if possible. That is, if the any production that's below demand will be consumed locally, so the benefit will be the retail price, and then the excess will be sold at the market price. Okay, so that's going to be the only technical slide of this presentation, which is what is the core of a game. Basically, we have a game that's cooperative, and you need to find a way that every allocation satisfies everybody. That's in game theory, we say that the game has a non-empty core, and in particular that the allocation that we chose lies within the core. So here, that's the mathematical presentation. Let's look at so this allocation here. That's the sum of xi. Xi is the gain, whatever money, the euros I get at the end of the year. The sum to each of the members of the community must equal to the value created by the larger community. Okay, so there's no loss or creation of value. Everything that's created by the community goes to the community members. The first, sorry, I should use the pointer probably. And the first line that you have here actually is the most complex one. It says that if you take a subset of the community, say 3 members out of the 6 members, you sum their gains. This sum of the gains must be greater than the value of the community, the value they would have if they would form a community of their own. Okay, so the gains within the community are greater than whatever value they would create if they would break the community and do another one. Okay, so we look for situations where the game has a non-empty core, and we look at the allocations. So, well, here's just the basic results of simulations. I'm going fast because I want to stick to my 15 minutes. So you have 6 people in a given building, have specific characteristics. If they would, so I'm going to try to potentially to draw something. Yeah, can I draw? I forgot where we draw. Okay, so the line individual value. So for example, you see 40 euros.9. That's the value that a couple working would make if it would invest alone on a PV panel on the roof. Okay, so you can see that the sum of the individual values, so if everybody stays alone, is 300 euros per year in this setting. If they form a coalition, if they form a community, this jumps to 500 euros. Okay, so this coalition is desirable. We need that from a social perspective. However, what you can see is that the allocation, for example, the per capita or the per volume, the per capacity allocation, they are not in the core. Okay, that's the right hand side of the table. Okay, this is here. Yes, I found it. So here, there is a very obvious deviation, which is that the storekeeper, who is here, now if you give him a per capita allocation of 80 euros, he will say, okay, I'm better off alone. I'd better just do my own community, that is no community at all, and I will have almost 200 euros of benefit per year. Okay, so this is an obvious deviation. Sometimes the deviation is less obvious with other sub-coalitions who would like to form. Okay, so usual allocations, they fail. Here we propose the Shapley allocation, which indeed lies in the core, so that's good news. However, what you can see is that it's extremely inegalitarian. Okay, so we are very far from the spirit of the péréquation tarifaire. Okay, the same price for everybody. Here you have heterogeneous load profiles, so and therefore you need to have heterogeneous benefits from the community. Okay. I'll keep going now, but well, that's the key idea of the first paper, which is the allocation needs to be inegalitarian for the community to survive. Actually, then I will talk a little bit about the snowball effect. That is this phenomenon through which, given existing grid tariffs, some communities might form, but not all communities. Then, given the community formation, then the grid tariffs are modified. Typically, they will increase. And following this modification, new communities will be pushed or forced to form as well. So that's what we call the snowball effect. So the setting, again, is the simplest we could think of. You have a neighborhood of 2 buildings. They are in a very small network with one DSO, which has to cover its cost. In each of these buildings, an energy community might form or not. And the communities, as usual, they mutualize the investment in PV, and also we had batteries here in this setting. So we assume that the DSO has 3 levels to recover the cost: a fixed part tariff, that is a connection fee; a capacity-based tariff, that is you pay pro rata of your peak demand over the year; or a volume-based tariff. We also allow for explicit coordination costs. Okay? If you want to build a community within your building, you have to aggregate into an assembly of joint owners. And so it takes time, and the more you are, the more complex that is. So we allow for these explicit costs. So again, I jump to the numerical results. That's going quite fast, but I am going to try to really highlight the main results that we have. So here we have three scenarios. One where the DSO only charges per peak capacity, per connection, or per kilowatt hour. That's the volumetric one. Okay, so what we observe is that the initial value, that is the one without any community of the tariff, is quite low, and it increases as communities form. Okay, there is this snowball effect that always results in the grid tariffs to increase. So from, for example, 50 euros per kilowatt to 300 euros per kilowatt in our setting, where indeed you have a snowball effect where more and more communities do form. Another result I want to highlight is that the installation of PV and batteries is excessive compared to social welfare. Why is it so? It's because basically the communities sort of try to escape their contribution to the network, and therefore they overinvest in PV to, for example, decrease their volumetric contribution to the grid. They invest in batteries, for example, to shave their peak demand, and this translates into grid tariffs having to increase, and also an excessive amount of investment within the communities. So overall, we do see that, for example, the per connection fee is the one that creates the biggest community. So here, that's the final partition within the two buildings. So you see that if you have per connection fee, they all form a single community. That's what you have here. On the other, with the other connection fees, grid tariffs, sorry, the communities are a bit less trivial. What we observe also is that the type of fees that maximizes social welfare is this one. Okay, here the final welfare is 880 euros per year, which is not so far from the best welfare. That is the one that would arise if there were no issue of coordination, if basically you had a dictator forcing people to invest on their own. Okay, so I guess I'm reaching the 15 minutes that were allocated to me. So yeah, a quick recap. So I want to stress that simple sharing rules, they usually fail to induce stability in the community. So we need something a bit more sophisticated. Energy communities have a risk to overinvest in renewable technologies because of inefficient grid tariffs. And finally, there might be a snowball effect that derives from a conflict between the mutual interests of the communities and the public interest of the more general grid. Okay, so with this, I will conclude, and I will give the floor to Jonathan, I guess. Yes or not? Yes.
Yes. Thank you very much, Xavier.
Yeah, I hope the connection was good enough. It always highlighted to me that the connection wasn't good, so I hope you didn't lose me.
I heard you pretty well, clear.
Okay, excellent. Thanks.
Thank you very much. I think it's really important to look at the sharing rules, especially as more people invest in like batteries and all those active devices that are kind of fighting to capture some of the value of that the community is generating. Now we'll pass the microphone to Damien PICAULT from ENEDIS, who will give us the point of view of DSO on the collective self-consumption.
Yeah. Good afternoon, everybody. Can you hear me correctly? Hope so. So I'm Damien PICAULT from ENEDIS, and I'm Smart Grid's project manager in the Lyon metropolis area. Thanks a lot, Jonathan and Lancey, for organizing this event. And so I want to give you a perspective on collective self-consumption operations that are going on today, and a point of view from the DSO. But to start off, maybe to get everybody clear on the role of ENEDIS, we have a short video that presents our activities in France. Maybe Jonathan, you can, or Marine, if you can launch the video.
For ENEDIS, the electricity network is everyone's concern. As a public utility company, its purpose is to manage and operate the French public electricity distribution network. Driven by a sense of fairness and transparency, the 39,000 ENEDIS employees make every effort to supply electricity to their clients, wherever they are and whoever their supplier is. Out in the field 24/7, they are committed to providing the best local service. As electricity emergency services, their work involves repairing damage caused by extreme weather and restore the supply for homes and businesses as quickly as possible. Come rain or shine, their guiding principles are true commitment and fast response time. With ENEDIS, tomorrow starts today. Over 3 billion euros are invested every year nationwide to modernize the grid and improve safety and performance. Working alongside its partners, ENEDIS is building smart grids, the intelligent networks of the future. This digital technology is essential to the deployment of renewable energy and to the emergence of new applications such as electric vehicles and connected objects. The new Linky Smart Meter is at the heart of this development. It provides clients with valuable support, opening the way to a new range of services for communities and individuals. Through its commitment, ENEDIS is playing a key role in the energy transition, and every employee is dedicated to contribute to inclusive and sustainable economic development for all. Every day, the men and women of ENEDIS are creating the public electricity service of the future.
All right. So now that it's clear for you, I hope the role of ENEDIS in our public service missions. Let's get back to the topic of the day on collective self-consumption. So thanks Rita and Rémi for the great job you've done talking about the legal framework and what actually is collective self-consumption. So I'm gonna go much more rapidly on these subjects. Just in a brief word, it started with the Energy Transition Law in 2015. And just last year, an order was published to extend the geographic perimeter to 2 kilometers and with a 3 megawatt production. So it's a story that's ongoing, and maybe some other evolutions may happen in the French Energy Code concerning the collective self-consumption. As it was said earlier, we're talking about artificial person. So that's the PMO that Rémi was talking about. The idea that we have both consumption and injection points that are located on the low voltage grid, the public distribution network, and that have a limited zone of 2 kilometers and a maximum generation of 3 megawatts for now. And of course, to actually treat all the data and the information in this collective self-consumption scheme, each consumer and producer must be equipped with a smart meter, so a communicating meter. The Linky meter that you saw in the video for smaller power levels. Today, if we take a photography of what's happening in France in terms of collective self-consumption operations, we have 34 active operations. Let's say the region with the most operations actually in the north of France. And it reunites about 520 participants total with 68 producers and 451 consumers, as you can see on the picture of the left. So it's something that's increasing since 2 years of the creation of the concept. And we have also 41 projects that are in pipeline that are going to be coming soon, hopefully. In terms of the types of artificial persons or PMOs that are being running actually these operations, we have a majority of local authorities, a part of social housing, and finally 11 operations are with other types of PMOs. That is to say, mostly associations, as Rémi was mentioning before. And finally, most of the operations that are ongoing are related to the first version of the technical constraints needed for to have a collective self-consumption scheme. That is to say that they are downstream of the same medium voltage and low voltage substation. Only 6 today have actually benefited from the extended rules of the 2 kilometers and 3 megawatt peaks. Just to say that earlier, with the older version of the collective self-consumption scheme, it was 100 kilowatts peak power production and below the same substation. So that was very much a bigger constraint. And today, hoping that the geographic parameters are going to increase the number of operations that can benefit this. Going forward, I wanted to mention some the process actually of how to implement a collective self-consumption operation. So as it was stated earlier, there's a contract that is signed between the artificial person or PMO and ENEDIS. Of course, each consumer and producer must be connected to the public distribution network. The production next can be either totally injected into the grid or partially consumed. So that's a individual self-consumption, and surplus is put into the grid and then virtually allocated to the different consumers of the operations, and therefore both generation and consumption flow on the distribution network. In the 4th step, you see that the contract has to be signed between the PMO and ENEDIS, and if once the amount of consumers and producers are identified, there are some technical aspects that are monitored in order to see if they are today equipped with smart meters. And if it's not the case, ENEDIS' commitment is to accelerate the deployment and equip the consumers in most cases to have these smart meters installed in order to participate to the operation. So what does actually the DSO do to accompany this the self-consumption operations? First, ENEDIS collects the data with a 30-minute pace. And that's why the necessity of the smart meters is really essential. Both consumption and generation data in order to synchronize the part that is actually self-consumed. So here you see on the figure of the left, we have 1 PV photovoltaic producer and three consumers. And then ENEDIS does some calculations that are using the allocation key that is provided by the artificial person in order to calculate the share of the generation that is allocated, and then therefore determine the part of self-consumption, that's the green part, and also the complementary energy provision. In the case of PV, it's very clear that during the nighttime, it's going to be hard to have some local production, so that has to come from another energy provider. And ENEDIS calculates the amount of energy that is actually complementarily provided. And also for the overall, the surplus of energy that is injected into the grid and usually, mostly, let's say, managed by balancing responsible parties. And then all of these information that are calculated by the DSO are then published and transmitted to the people that need this information, depending on their roles and capacities. So there's the artificial person, the different energy providers, especially for the complementary energy provision, and balancing responsible parties, as well as the producers. So if we talk about two ongoing cases, I wanted to mention the first operation, which is collective self-consumption in the Lyon area in a city called Villeurbanne, and it's actually the first operation only between companies. So in this case, we have a PMO, which is also an energy provider called Urban Solar Energy, who has installed in 2018 67 panels to accumulate with a 20 kilowatt peak power. And he's actually providing energy to the commons. So if we look on the scheme here, the PV installation is directly connected to the commons. So there's some individual self-consumption to provide energy for the elevators or the common lightings. And then the other parts are sold to the companies that are within the building. And all of that, of course, on the public distribution network. So this is an ongoing operation that was inaugurated last year in May 2019. And for now, everything seems to be going smoothly. So if ever you're in the Lyon area and you pass by this building, you can see for yourself the collective self-consumption in action. And another interesting project that is under construction that I wanted to mention is something happening in the Confluence district in Lyon, which is a very, let's say, environmentally organized and has many initiatives to be a low consumption district. And there are some buildings that are supposed to be delivered at the end of this year that are under construction in Ideal Confluence. And then there are 5 buildings that are going to be equipped with PV panels and battery storage. And the idea is to begin a collective self-consumption scheme with the tenants that are both residential, but also companies that are going to be in a startup, a co-working part of this building. And so that's something that's supposed to be going into operation soon. For information, this is the PMO of this type of this operation is going to be an association. So it differs also with the previous example I wanted to mention. I think I've been talking sufficiently on the time. If you want some more information on how a self-consumption can work, I would be happy to answer some questions, and you can also check us on the internet on the dedicated page. So thank you very much.
All right, thank you very much, Damien. That was really interesting. Now I will pass the microphone to Youssef from GreenAlp, also a DSO, who will give us their point of view on this autoconsommation collective.
Okay, Youssef, you have the right to activate your microphone and camera. Yeah, perfect. Thank you very much.
Okay, so hello everyone, and thank you all the presenters and all the participants so far for the preparations of all that has been done. So Damien just said much things about ENEDIS that will be also operative for GreenAlp, and what I like to emphasize is why do we have some other DSOs in France, and then what specificities can we have on the grid, and some starting from one project that is ABC that we'll see together. So GreenAlp, who are we? We are local DSO, what we call in French une entreprise locale de distribution. And why do we have this? It has in the creation of such local DSO starts with the beginning of the energy sector. We started as a gas distribution company. We had a gas manufacturer, a gas plant in Grenoble, so we started as a gas distribution in 150 years ago. Then we added electricity, and then after Second World War, you had a big nationalization that created EDF and GDF. And at that time, the city of Grenoble decided to keep the Régie, Gaz et d'Électricité as a public company. So there have been many companies like this that kept local in France. Then later on, it became a semi-public company. So till today, it's still owned half is ownership. The stakeholders is the city and the métropole de Grenoble, and the other half is industrial partners, institutionals, Caisse des Dépôts, etc. Why this historic is important? Because, as you saw, we started first on a city, Grenoble, and then we started to have an extension on the network. And on this, and you see on green, it's the counties when we are operating the DSO in electricity. And so we have our network is not connected all over. So for when we're talking about communities, when talking about self-consumption, it has some impacts. And we also have two energies. We have power and we have gas. And in gas, we have natural gas and we have propane. So when we're talking about energy communities, we have, of course, the legal aspects of the power, but then we have also in our clients the gas part, and this is something we have to be keeping in our own reflection. So sometimes we might be a bit schizophrenic on that. If we go deeper into self-consumption, we have one example in the city of Grenoble that is called ABC for Autonomous Buildings for Citizens. It has been started in 2014 by the city of Grenoble, by Bouygues Construction, by Link City, by GEG, of course, by Grenoble Habitat, social housing, by Inovia. So as Rémi said, it's not by citizens, it's social housing and the city that wanted to start that. And when you see it, you cannot miss it. As you see on the picture, the PV panels are quite you can recognize them far from the building, and that's because they have not only a function of power generation but also of water collection. So the building that has been designed from zero combines the different actions: energy, of course, but also water, also waste reduction, and also well-being. So it claimed to be the first autonomous building in France, and it wants to demonstrate this global approach. On water, it goes down to almost half of the consumption of equivalent households. On energy, it's up to 70% of consumption that will be covered by PV. On waste, it's 40% decrease on waste, etc. So it starts also with the building of the materials that used for buildings. There's a low carbon concrete that has been used by Vika, the one preparing the construction. Of course, we have been talking already about isolation. So here also the thermal isolation plus comfort is key to reduce the consumption and thus to increase the part the PV is playing on the global consumption. So let's focus a bit more on what we have on self-consumption. So the building is designed for 62 flats, a total of 5,000 square meters. All the flats are equipped by low consumption appliances. They're also equipped by Lancey heaters that Raphaël presented in the beginning. And on the energy generation part, we have 1,130 square meters of PV panels. It's 209 kilowatt peak. There is some battery storage as well, and there are 44 kilowatt peaks that are dedicated to self-consumption. So all the setup aims to increase from 20% up to 70% on the yearly energy coverage. It just started. The first inhabitants came in this summer. And the first, the unveiling, the official unveiling will still have to be done later in the autumn on the winter. But first, on the first inhabitants, we have merely 43 participants out of the first 52 inhabitants. So, like this, as we have already been saying earlier today, it's the social landlord that is the PMO. So it had the opportunity to ease that and to ease the participation of all inhabitants. So here we are. The building has been created as a self-consumption operation, and then we are recruiting on the inhabitants who wants to be part of it and who's not willing to be part of it, and we see quite a success on that. For us, for the company, it's quite a huge revolution. It's the first case we have such as. So we are in the basic model. Xavier, not Xavier, in the basic model that has been showed earlier by Rémi too, not extended. And why was it such a revolution? Because first we are not yet advanced on the smart metering deployment, not as ENEDIS. We're just starting that. So we had to, it fitted our calendar, but we had to equip the building a bit in advance for that. We had all the contractual engineering and the PMO have been discussed already to set up. But it also had a lot of impacts on the invoicing, on the IS, on the legal, on the communication, on the supervision from on the SCADA systems, etc. This on the DSO part, but also on our colleagues, because GreenAlp is a subsidiary of GEG, Gaz Électricité de Grenoble, that also has the role of supply. So they also had on supply management and supply contracts, they also had some work to do on that. What kind of impacts does that have, and what are the challenges ahead of us? The DSO gets its retribution from tariffs. When you have self-consumption, you have less transit. You have then less decrease in your tariffs. So all the economic model might be is affected. At what scale? It's not today. It's one operation we have on our 120,000 clients. So it's not that big, but it's the beginning. This one for self-consumption. We have also individual self-consumption that is more common now. Impacts as well on legal and the regulatory. We have been discussing already the limits: 2 kilometers, 20 kilometers, 3 megawatts, etc. Those are to be monitored and by us. And there is one limit that is not likely to be moved. Is that substation behind the same substation? No, this has been removed, but still it stays behind or on the same DSO. If you remember the first map I showed, we had Grenoble as a green spot in the middle with GreenAlp as the DSO, but all the cities around Grenoble are operated by ENEDIS. So mainly, if you go close to the frontier between to the border between Grenoble and those cities, then you have only one side that is eligible to the self-consumption. Another building that will be on the other part of the street, but on an ENEDIS side, then cannot be used within the same self-consumption operation. We have a huge also impact on IS. All our information system was not designed to cover anything that was linked to self-consumption, was it individual or collective, and this is quite a huge impact because we are dependent on some tools that are used by some other companies too, but that are not easy to make them evolve, and are not easy to take into considerations those very specific items. What are the challenges ahead of us, and what are kind of ambition of GreenAlp or DSO? First of all, and it's to be able to ensure our DSO. And this DSO can be technical on the electrical junctions, on the metering, of course. It can be contractual, so all the definitions of all the type of contracts, what kind of contracts, what can be done, what cannot be done, etc. We can also, and we have to have some support to the customers, and specifically on regulatory, what can they do, what they can't be do. And at the end, in our in our DSO, we have all the data management behind, the publications we have to do for individuals, for companies, etc. But also all the what we call the récoflux, la reconstitution des flux, to identify all the energy movements. What we have been able to do so far is tailor-made. It's tailor-made on this operation for ABC. And now we have to make it more robust. It's tailor-made, and sometimes we have to say artisanal. So we have to make it more robust and then industrial. There's also a matter of scalability. It was the first operation. Then we are looking for others. We hope that others will be starting a new self-consumption collectively, and we have to be able to scale what we have been done to the others, to the next comers. The IS, I already talked about it. We have to modify, and all those flow and modelizations are to be redefined. And then there is a big question: is how can we foster some collective operation? Have been said earlier, there was one project only started by citizens. How can we, GreenAlp, as we are very local operators and GEG globally, how can we foster some citizens to go ahead and start, based on citizenship, and start a new project? How can we help them? How can we make them understand this so that they can start? They have all the keys, so that they can start that. And then for the future, we have some open questions that remind. How can we be, as a small company, to GreenAlp? I didn't say that at the beginning. It's 200 people, all in all. We have the gas and power, everything. It's 200 people. How can we be proactive on the regulatory definitions? How can we be a role? How can we play a role on that, or can we just wait and see what happens and say how could we apply that to our scope? How can we be active or not on the technical standard? What's for tomorrow on the storage? Storage capacities can be of help for us because we are a small DSO. We are connected then to the TSO, the transport system operator RTE, and we have to be very careful on our peak demand as a DSO globally, because this has major impact, financial impact, if we go over our capacity that we have with RTE. What kind of additional services can we provide as a DSO? What kind of additional services can we provide to customers that are going into self-consumptions? More than the basic services that we have to, can we provide some additional services that will help them to go on that, or that we make for them some new additional values? So all those questions are still open for the future. We are working on that also with the neighbors, ENEDIS, amongst others, almost with all the others, the other local DSOs as well, and then see how tomorrow we can foster that communities. And I will end on some other part of energy communities that are not contractual or mainly linked to electricity. We also have, and not only linked to renewable. As I said, we also have gas, and we need this complementarity. Roughly 40% of our households have both energies, gas and electricity. So we have to keep in mind this bioenergy in all our processes. And within this energy community we want to foster, there is one that is interesting, even if it has no financial benefit for us. It's how can we give the keys to the inhabitants to better understand their consumption, the energy consumption. Should it be electricity? Should it be gas? Should it be on our system, on our distribution system? Should it be on ENEDIS and GRDF, so meaning the whole metropolitan area? The consumption also on central heating, on water, and also why not on wood, if for those who have some heating with wood. So the idea behind, and there's a product that has been designed on that, and that is being rolling out this winter and early next year, is Metro Energy. The idea is to have a global platform for each inhabitant to be able to see, one, his consumption, two, the comparison with other households, and with that, creating the keys, giving them the keys to start to feel and act like a community, should it be in a building or neighborhood, or sometimes maybe, why not, with other actors, so that they start a self-consumption, collective self-consumption and power. So that's it for me. I'm just over my 15 minutes, I think. And if you have any additional question on this, of course, with pleasure.
Thank you very much, Youssef, and thank you for bringing all this challenge, but also explaining how you're doing in GreenAlp, and also reminding us that those community can be multi-vector, multi-energy, and then one of the key point is for people also to understand what they consume, and that's one of the objectives of those communities. So now I'll pass the microphone to Margot Husson. She'll present us what she gathered from all those presentations and what she might have drawn.
Est-ce que vous m'entendez?
Oui, c'est bon pour moi.
Ok. Moi, je vous entends seulement à travers le téléphone qui est à côté de moi, donc j'espère que ça va bien marcher. Du coup, j'y vais. Je vais attendre que Marine mette en place le visuel. Voilà, super. De mon côté, donc je suis... I'm going to talk in English. Okay, so my name is Margot Husson and I'm a graphic facilitator. So I'm not an expert in this field, not at all. And I think in this community, I'm being the random citizen that you were talking about, the one that doesn't quite understand everything, but that has this outside point of view, looking into what is an energy community and how does it work and all the different actors. So what I've been drawing while listening to you is this visual. So you see in the center is what I've understood as being an energy community, and then you have several like clouds and bubbles related to each presentation. So I'm not going to go through every presentation again, but just so you have an overview, and then I picked some elements that I felt were really interesting. So maybe to comment on that, not on everything, but on these elements mainly, and I will let Jonathan react as well on that. What I understood is that there's an ecosystem of actors that you represent, all the speakers, and that have common goals, that is to create carbon neutral energy systems for the future. And this ecosystem of actors is trying to develop and support these energy communities in their efficiency, in their viability in the long term, and how to create viable business models, and trying to give them support and resources. And for me, this ecosystem of actors, there's like something at stake that is being maybe cooperation between you. Like I was trying to figure out and see like how can Enogrid work with ENEDIS and stuff, and are you connected, and are you working together with each of these energy communities? So I think that if I had a question, would be like, how do you cooperate with each other? And I also noted this that has been said in a few presentations, that there is this complexity issue of like specifically in France, that is like who is the PMO, what type is it, and how does it work with the DSO and everything, and how do we share the value, and maybe we need a sophisticated system to figure out the tariffs and the grids and all the impacts. And as being the random citizen here, I think it's really key to think of this complexity and try to work together to give better understanding of this. And I think that's a key to develop more energy communities. That's my point of view. Like on the visual, you will see some stuff that I've been thinking that were essentials to what is said. And then that's my point of view, asking about cooperation and complexity of this system. Okay, Jonathan, maybe you want to react to what I said, or say something complementary, or say something really different?
No, I won't say something different. I think it's a great job and great visual. I really like it. We'll definitely share it with everybody afterwards. You're right that it is a bit complex, and it's still something growing. I mean, we've seen, I think, 34, 36 existing projects in French. I mean, at least for the ENEDIS territory. And people still have to kind of understand how we build those communities, and that's also the work of Enogrid, of kind of enabling those, facilitating at least those either social tenants or either association to create and to create and foster those communities. Cooperation, also united cooperation, that's important. I mean, cooperation between those PMOs, those association and ENEDIS and the DSO. It's also a lot of work, I think, for ENEDIS and the DSOs in general. I mean, GreenAlp definitely is experimenting that. I think this is a lot of data that comes, a lot of data that they have to meter from those community to enable like sharing all those different flux of energy and how to share this value. Is a tricky thing because you need a decent infrastructures, IT infrastructures to enable that, and even more to enable what Xavier Lambin talked about, and all those a bit more fancy rule of sharing, of way to share the value through the community. But those rules are important because tomorrow you will have like all those communities, and you want them stable and not having them splitting up because there would be more value in like making a smaller group. You really want to construct something that has meaning. So I don't have much. This is great visual. I think I will open the floor to questions because that's what I think is more interesting for me instead of listening to me. And so. So I'll open the floor for questions. Don't hesitate to ask question
by clicking on the.
You can click on the question mark in the chat to ask a question. We have 25 minutes of question if you want. So we have time for question. I will go ahead and okay. So I will address the question to all the speakers, unless I guess maybe we can have all the speakers in. What tool have the speakers used to engage the resident or tenant in the building? So I guess that's a question maybe for Enogrid, maybe to give us a bit of perspective on how they help the PMO. So Rémi, how do you help the PMO kind of getting everybody involved in those community? Can you?
Yes. Yeah, good question. So what we were talking about cooperation. What we do is we do the link between the large amount of data that the DSO is producing during collective self-consumption. We have a tools, which is a web platform. Basically, it's a management tools of collective self-consumption that we give to the PMO. we take all the data from provided by ENEDIS, by the DSO, and we make it understandable, workable for all the participants. So that means the PMO will have all the information, technical information, to know what is happening on his operation, and all the participants will have their private, let's say, private information about what they are consuming, what come from the grid, what come from the local, etc., etc. So we think to engage the member of the community, we have to give them information. So our job is to give them the right information in the most understandable way, because we are speaking about people who are not energy experts. So we have to find the good way to show them the data and to make them understand what is going on the community.
Thank you very much, Rémi, for this explanation. I will follow up, I guess, with a question to Damien PICAULT. I guess we have few collective self-consumption projects in France. I wanted to know your opinion on what could unlock more of those communities to grow, and what would unlock those communities to have more communities in France.
Thanks, Jonathan. It's a tough question. I don't have a magic crystal ball to find the solutions. Just to ask, an aspect I want to mention concerning the previous question is that as DSOs, we are enablers of self-consumption, collective self-consumption schemes, but we don't have a public service mission to develop them. Looking back to your question, in my opinion, the main aspect to kind of stimulate even more projects, as I was mentioning, we have 34 today, 41 projects in the pipeline, so we're expecting it to grow. I think it's mostly knowing that it's possible, and kind of the work maybe that Rémi is actually doing to trying to build them by assisting the PMOs and having a role to try to make it happen. I think that's the main thing to do. So basically, gain knowledge on the how it's possible to stimulate the citizens and also local communities. We have many projects coming in from social housing. I believe that's a real driver to make that happen. So yeah, that are just some of the outlooks.
Thank you very much. Thank you very much, Damien. That's a tough question. Okay, we have two more questions. I guess a question from Sylvia for you as well. Maybe we can put it on the, yeah. Could you please explain the advanced smart metering infrastructure, which will be used on the Confluence project?
Sure. Yeah, smart meters is just a term. So I'm talking about the linking infrastructure. There's another term used that's called advanced metering infrastructure. And so we're using the same smart metering infrastructure. So it's mainly with Linky, because the 5 PV plants are going to be 36 kVA, so which is just the limit for using the Linky smart meter. So we're using the traditional. Now it's going to be traditional because we're finishing the rollout, but we're using the Linky smart metering infrastructure. And for the battery, which will be 50 kilowatts, it's going to be using another type of meter, but with the same protocols, and that's compatible.
Okay. We have a question from Xavier as well. Maybe we can put it on the screen. And I think this is a question for both you, Damien, and eventually Youssef. The first part of the question is it good that those energy communities are popping up a little bit everywhere for DSO? I guess it's a question of like, will it modify the tariff structures? Maybe for other customers of those that are not in those energy communities, kind of I guess the question is, what will become DSOs if everybody is part of an energy communities? Yeah.
Yeah, it is a complex question. Maybe I'll go first, and then I'll let Youssef maybe add his vision. But for sure, it's a new type of let's say actor or stakeholder that which is the PMO, the artificial person, and another way of using the public utility grid. So it's going to add some complexity, but with the first operations that are going, there's no major drawbacks that we're seeing. Considering the second point, which is will finally energy communities replace DSOs? I don't think that's I don't share that point of view, and it's not too much of a risk in the sense that the main basically the public distribution grid is the infrastructure that's making these energy communities possible, and so it's basically a layer which is really at the bottom, in which people are going to invest maybe in new distributed generation units, are going to engage themselves in trying to interest themselves more and become part of this community. And all of that, finally, the link, which is connecting, and it's the essence of the distribution grid, is finally the DSO. So no, I don't believe that it's going to make them obsolete. I think everyone's really now going to more know what the role of the DSO is, besides fixing cables when there's some big hurricanes or some heavy rains. So no, I'm more positive and let's say enthusiastic about that.
I mean, definitely we can see that the DSO has a big role. I mean, it's playing a big role to enable those communities right now. So I guess we'll definitely need it later on as well. So I don't know if Youssef is here to answer as well. Else, if we can, maybe Youssef, if you want to, if we can put it, yeah.
And I don't think the EC energy community will replace the DSO, but rather the DSO will have his role has to evolve from a top-down distribution, from transport to consumption. Now the DSO is between transport and consumption. We'll have much more up. How do we use the up part? So the bottom up from more production, decentralized. How to be able to explain to everyone that this is feasible, this is possible, and this has an impact on their at the end on their own tariff. So from the financial point of view, there may be two things. One is, yes, there will be some impact on our tariffs. It has been shown also by Xavier in the first paper earlier. But there's also one on the financial for the end consumer. We are public companies, so I think even if it's not in our mission to promote and to develop self-energy consumptions, it's somewhere in our mission to be able to explain energy and to make end consumer have a better understanding of what his consumption is and how to reduce it. We have been talking also earlier about energy poverty. This is something that is quite important, especially in we will see how those last month of crisis will emphasize this movement or not. But this energy poverty is a big issue also on those networks. And so, if self-consumption is one way to provide those households with a cheaper energy, then it's also somewhere in our mission to enable that as well.
All right. Well, yeah, definitely. And I guess kind of moving on a little bit on this answer, I think we've seen a lot of the collective self-consumption project having one big producers or one big battery do you see communities that have many where all the different participants have their own generation? All the participants can be consumers, but also producers, having eventually their battery. Like, I guess my question I'm getting at is, will it be possible for all the people in the community to be producers and participate actively, as opposed to having one big one big producers?
On our network, maybe not, because we're mostly urban, dense areas and grown up. So I don't see that easily that each household has its own PV panels on the top of the building. It's either a collective one or within associations such as Énergie Citoyenne or others. So I think on such dense areas, no, we will not see that. Rémi might have some more incentive on that, on what's going on more on less density areas. If anyone can have a solar panel on its roof, is it enough? Is production enough to make everyone on the same consumption, or does it stick to individual on that side?
Yeah, I'm curious, Rémi, if you can give us a bit of information on, like, did you see more complex energy communities where there was maybe 5 producers?
Yeah, it's today I think a majority of the project are with only one producer. It's starting to change because of one reason. The main reason is the new perimeter. Before, when we were on the let's say on the technical perimeter behind the same post, it was a little bit complicated to identify two producers. But now that we are on the 2 kilometer perimeter, it's more easy. We are starting to see few operations where we have 2, 3, 4, 5 production source, which is interesting. But still, it's still energy community which are let's say pushed by local authority. The case you refer to with a neighborhood where every citizen has a solar panel on his roof and they are sharing all electricity all together. We have not seen that so far. But I don't think it's because of one. The question is not about one producer or 2 or several producers. It's because so far the citizens themselves the process is too complex for them to start a collective self-consumption.
Okay.
But technically, it's possible. You can have as many producers as you want with with a limit of 3 megawatts. Yes, 3 megawatts. You have space for a lot of producers.
I see. So we've heard, I guess, recently, and this is mostly for the French case, but we've heard recently that those collective self-consumption project may be extended to a 20-kilometer perimeter. I guess.
Careful about this one.
But I guess my question is more about not so much about the 20 kilometers, but does it make sense to extend it that much, or does it make sense to? Because this is supposed to be kind of local communities, and I guess we hear a lot that it's not so much about better producing, but better consuming, and so. What it seems to be great in those projects is that people kind of grasp a little bit better what is their electric consumption, and if we have to, if it's enabled in a 20-kilometer range, then I think we might lose a little bit of this kind of.
It depends where you are, in which where you live, because to make the story of the 20 kilometers, it's actually a discussion that is ongoing, and the request is to ask for exception of the 2 kilometers rules when you are in the countryside and when within the range of 2 kilometers you have not enough people to have an energy community. So they ask for exception when you are in the countryside where the density of house and population is very low, to extend this this perimeter to 20 kilometers to be able to gather enough people.
Right. And that makes sense in that case, right? So we have,
if you make 20 kilometers area in Paris, there is no sense. 2 kilometers is more than enough.
So we have a question from Antoine. That's quite a long question, but I guess kind of summarizing a little bit at the end, like what parameters, size of the project, profile of the consumers can influence the choice between self-consumption and 100% sale. I guess when do you choose to have this self-consumption versus just feed-in tariffs, selling everything? And I guess that could be a question for you, Rémi. Eventually, Rita, if you want to also come.
Me to answer very quickly. Today, for if you make a very big solar panel plant and you are thinking only about financial aspects, you will make 100% sales. After the question I'm dealing more with my client is, do I choose individual self-consumption or do I choose collective self-consumption? That's where we start from. When people are I have never seen people hesitating between 100% sales and collective self-consumption.
Okay. Rita, maybe you have some idea.
In terms of, you're right that there's not only the economical point of view, there's also the social aspect where collective self-consumption project or energy communities project brings local jobs, brings people together, which is quite important as well. There's also the aspect of optimization. If the energy produced is consumed locally, then there's less losses, first of all, in the low voltage or high voltage when the electricity is transported. There's also the educational part where energy communities project can sometimes have a holistic approach where there's also a little bit of education and where there's program with energy efficiencies as well. So it's to my point of view is the holistic approach and the optimization approach as well that is really interesting compared to selling the entire production.
Mm-hmm. Yeah, definitely it's definitely interesting to see those group of people and kind of rethinking about electricity as a local. We have a comment from Youssef. Right. So I guess what Youssef is referring to is that the ABC building is both a part of the solar panels are for self-consumption and part of it are just for feed-in tariffs, sold to the grid. I guess I don't know if you guys have any more questions. I will give you a couple seconds for any question. We have a question for Xavier.
Online now. So yeah, the question is about whether we compared our model to existing communities and their profit or sharing. Yeah, excellent question. So what we have is indeed a theoretical model and numerical applications that are simulated. So indeed, it's important to see whatever is done elsewhere. In fact, there is quite a large diversity of sharing rules that have been chosen. In the French case, the Commission de Régulation d'énergie allows the PMO to choose pretty much whatever sharing rule it wants, but the default is a pro rata of consumption. So we argued at the time we created this research that was concomitant with the creation of this regulation that it's actually good news that at least the PMO is allowed to choose its sharing rule. However, the default is unlikely to be satisfactory. The default has probably been chosen because it really looks like some sort of péréquation tarifaire, tariff equalization. But overall, I think it's a good news that the energy communities are questioning a little bit this old model that we have of tariff equalization. And precisely with energy communities, I think there's a new debate that comes in, which is, is it a good thing at all that that all consumers should pay the exact same thing? And I think questioning this dogma is a good thing.
Yes. Thank you, Xavier. That's a whole new debate. Yeah. I think we are at almost 2:15. I think we'll end this now. Again, thank you for listening. We'll definitely send you the work done by Margot because that was really pretty, and we'll also send you a link to this recorded webinar because you'll be able to rewatch it eventually or share it with your colleagues. Again, thank you for your participation, and thank you to Marie Poul and Olivier Guérard as well at Lancey Energy Storage for helping to organize this webinar. Thank you for Marine to manage this platform, and have a great day.